Thank you, Ian. Can everybody hear me? Great. Okay, I've prepared far too much material, so I'm going to really rattle through it. If you want to stop me and go into more detail or anything, please do. I can just stop and then pick up where we left off. So I'm not going to dwell on what a listed building is because Tony's already spoken to you about that in the past. What I want to do is just initially think why we value historic buildings, listed or not, briefly what the differences are between traditional construction and modern construction, some typical defects, and then what we can do to rectify those defects, and then if there's time, hopefully there will be some case studies showing some projects that we've completed. So if we go to slide 3, please, Anthony. And the next one, slide 4. So here we have an example of some historic buildings, and they're very different in nature. We've got a whole village that was relocated at Milton Abbas. Really, its value isn't in each individual building, but it's just the thing as a whole. It was relocated so the capability Brown could landscape around the big house. Then we've got the County Museum, beautiful building in its own right, great quality craftsmanship, and then something there which is really very poor in the left-hand corner. It's absolutely sort of terrible condition, not really quite sure what it is, but there isn't much medieval painting left. And so actually, it's a very high significance, even though we can't really clearly tell what it is. I'm sure we've done some interpretation and you could project some light onto it and show how it is supposed to look. Although it's in terrible condition, still really significant and of high architectural and artistic value. The one on the far end is, the one on the far end is much more interesting. The church didn't know that they had this. This is in a church at Woodsford. They didn't know they had this gem, or they certainly had it, didn't appreciate it. They wanted to paint over it because it was ugly. I was actually stood down from that church because I said, don't paint over it, record it, repair it, conserve it. It's a very rare example of painting done by the incumbents during the war. There's all kinds of religious symbology on there with St. Michael with his wobbling sword, and I'd like to see that interpreted. But it's so why we value things, it's not necessarily because they're beautiful or because they're exquisitely made, or even because they're a particularly good example of their kind. All kinds of different reasons. And when we're thinking about repairing things, we want to bear that in mind. Is what actually do we value about this? Why do we repair it and not just replace it, or perhaps we can replace it? So if we go on to the next slide. There's a little pop-up. So that there, when I first saw that little window, I thought that was probably a piece of perspex or something. That's actually, as far as we know, the oldest horn window, still in its original position, certainly in the county, but probably in the country. And that was West Coker Church, if we're in that direction. The picture that popped up is a horn window at West Coker Church. Wait, please. And they're not always ancient. This is Wool Church, which was done by Anthony Jaggard and Ron Jones of our practice. It was listed in Anthony's lifetime. So construction, the next one please. So traditional buildings are really split into two after a certain period. You've got the vernacular buildings, which are made from what's available by ordinary people for ordinary people to live in. And then you've got polite architecture, which would be the country house, where they're trying to say something, make a statement, do something artistic, do something of more value. So go to the next slide, please. So here we are. There's a polite building. It's making its mark on the place. It's got a design intent. The next one, please. So historic buildings, you have solid construction with decent bases of stone on either side, and then some chippings and muck go in the middle, and pour lime in and consolidate it. And it works a bit like an overcoat. Rain hits the outside, And hopefully, before it's soaked all the way to the inside, it's stopped raining, the sun comes out and it evaporates. Whereas modern construction, you've got a cavity, so it's more like a modern anorak. Rain hits the outside, can't get in, and any water that does get into the cavity is directed down and out. Next slide. The reason I just mentioned that is because you treat the two very differently when you're considering defects and repairs. So, Dorset stone, the geology is quite varied in Dorset, and what you generally find is that buildings, certainly vernacular buildings, are built of what's around. When we get to the polite buildings, sometimes we might have some kiln stone from France or some bath stone or whatever, but I put that up because that's interesting, because a lot of the defects, not all defects, but some structural movements in particular will depend on what things are built on as well. There's an example of my Dorset detailing. There's stone and flint lying around, so rather than jumbling it up together, they've made something nice of it and banded it. Brick as well, lots of local brick buildings. We're going to rattle through these. So lime before, actually no, I'll ignore this one and go to the next one. The point with these traditional materials, they're very different to modern materials, and we treat them in a different way. Thatch is interesting, and also we've got both long straw and reed. If we go to the next slide, these two buildings here are thatched with different materials, even though in the same vicinity. I don't know if any of you can tell me which is which. No? If you click the next button, so the one on this side is the white house is reed, the other one is straw. They look very similar from a distance, and close up, they're also hard to tell apart. The thatcher will be able to tell them apart, but it's not straightforward. So we need to know what we're dealing with. And reeds are also used elsewhere, particularly where reeds are abundant. In our offices, actually, in Dorchester, some of the ceilings there have got lath. They've got reeds instead of lath, so the plaster is just pushed onto the reeds there. And pole rafters in some simple buildings, that's the Milton Abbots as well. So maintenance is important to prevent the need for repairs later on. And most of it is very straightforward and often neglected. So cleaning out gutters, inspecting regularly to check that there aren't any problems. You know, are the gullies blocked with their water puddling up? And quite often you find the front of the building and the rooms that are occupied are in good condition. But when you go up into the loft space, you spot lots of rots at high level, or you can see daylight through where there's missing tiles. And the key thing is to get on top of things quickly. Stitching time saves nine is the old adage, and it really does. If you catch a slipped tile within a week or two of it falling off, what you've got to do is put a new tile back in. Whereas if it's been off for a few months or even years, then you get water staining and damage to other materials behind, and then perhaps some rot, perhaps some woodworm, wood-boring beetles, and other problems. Go to the next slide, please. And there's lots of advice on maintenance. This was just pinched from the Society for the Protection of Ancient Buildings website. They do the booklet and information online suggesting how you can do various maintenance activities through the year to spread the load. And if you plan it and actually write it down, then you're less likely to forget all about it. There's another little advert for Facade. So some typical causes of damage. This is the fun part. There's some really grisly photographs, all from projects that we've dealt with. Dampness. These mushrooms are thriving, or fungi, thriving because it's a little bit damp, and it has been for some time. In this instance, it's probably a combination of the walls being drenched because the rainwater goods were just too small, actually, and probably regularly blocked and then surcharging and water splashing up from the ground, in conjunction with, because that wall is cold and wet, condensation forming on it. The next slide, please. This gutter, so again, this is a church. A lot of my examples are from churches because I do a lot of work on them, but same applies to houses or any other building. But here, all gutters around the edge, lovely and clear, painted, in good condition. The bits that you couldn't easily get to or see, completely and utterly ignored. And this has been like that for at least 5 years. Now here's a thing, poor design. I briefly had a slide on lime, and traditional buildings have had lime mortar. So limestone's crushed up, burnt, then becomes it becomes quicklime, mix it with mortar and some aggregates and put it on the building. And the beauty of it is that it is softer and more porous than the stone, and also it can accommodate over a long time a little bit of movement as well. The lime will dissolve into water and fill up any cracks. And what happens is, because it's more porous than the stone, a lot of evaporation occurs through the joints. And so the lime weathers away sacrificially in preference to the stone. And after, I don't know, a century or so, you end up with really deep open joints and someone needs to repoint it. And that was always traditionally done with lime, and it was an ongoing maintenance cycle. But when Portland cement became cheap, easy to use, popular, and it's really hard and strong, everyone thought that was a great idea, so they repointed using Portland cement, which is inappropriate because it doesn't allow evaporation of movement through the joints. That's the main problem. So then the evaporation occurs through the stone, and as the stone contains salts, those salts, the soluble salts, come to the surface and then get washed away. And the stone decays preferentially. Now here you can see that the mortar was splotched all over the face of the stonework, which just looks unsightly, and actually they've probably covered about 50% of that wall in cement unnecessarily, which has further exacerbated it, and the stones weathered away preferentially to the mortar. Timber decay, so when timber's damp, you end up with fungal decay, various types of rot, and also wood-boring beetle, which weakens it. And the advice used to be, well, you slap on some chemicals to arrest that decay. The advice now is that actually you make it dry. If you make it dry, then even though the rot might still be in there, it would be dormant and not really doing much. You can't always make it dry in a historic building without making huge changes. It's likely not to be a damp-proof course. So sometimes there might, in my view, be an argument for applying a little bit of damp-proof as well, but keeping it, try and get it as dry as you can. Corrosion. So here we've got some railings and rusting at the bottom. You can see that. It's obvious we could de-rust it and redecorate it, and eventually it's going to rust right through and have to weld a bit more on or do some other repair. Next slide, please. You can't always see the corrosion. This is Norton Subhandon Church. The pinnacle lying on the floor shouldn't be on the floor. That should be on the right. And it's actually quite a thing. It's huge. When you're looking up from the ground level, it's a difficult thing stuck on the top. But when you see it at ground level, absolutely enormous. And all that's holding that into place against any wind load is a little iron dowel. That had rusted, and you can't see it. So it's very hard to predict when these things are going to happen. But it rusted and then fractured the stone, and that's why that's fallen off. So that's where it should be at the top there. And the same thing happens on windows, where you've got ferramenta, the ironwork associated with the window built into the stone. The ends crack, the ends expand, and that cracks the stone. And so, so if you go back for one. So here there are various techniques, such as cutting off the edge of the. You can cut it back here, weld on a non-ferrous metal, and then build it back in, so you can retain as much of the historic material as you can. Normally that would be proportionate, but I've got a window at the moment with very rare hexagonal Art Deco tie bars, where actually it's not a simple thing you can. So all the time you're thinking, what actually is the significance of this thing? Movements. So the cause of this movement, you've got these cracks. These cracks were present in the outside as well as the inside, and they occurred over 2 or 3 years, and the end wall of the building was detached from the roof, which was leaning so much that the gap is about a foot at the top. And so we thought, well, what's changed? Why has this suddenly happened? And the reason was someone had planted a Leylandii hedge very close to the building. So the vegetation sucks water up out of the ground. It was built on clay. The clay then shrank and caused that cracking. The building was closed on safety grounds, and they cut down the hedge. And within about 2 years, the wall had gone back upright again, and just needed just to refresh the flashing over the gap, and it could be reopened. So that was a nice, simple one. Some mechanical damage. So this was due to lead theft. Someone decided to pinch some lead from the valley. I don't know what the lead was worth, probably a few £100, but in getting there, they smashed a load of tiles. Well, they probably caused more or as much damage for the bits that they didn't pinch as the bits that they did. So theft and vandalism, that leads on nicely to that. Here's some lead theft. Very difficult. Abbotsbury Church has just had a lot of lead stolen from the aisle. That had a full, that's probably 4 or 5 months ago now. Yeah, that had a full alarm detection system and everything. Probably an inside job. Someone knew how to disable the alarm, I think. But they can have lead off like this. That's probably, I don't know how long it takes, maybe half an hour, just quickly with a standing knife and throwing it down to the ground. At White Regis, they did it in broad daylight. They turned up in a white van with high-vis jackets and ladders and just did it, and no one questioned it. And next slide, please. And then there's just natural decay. Nothing lasts forever. Things weather away. This stone was ornately detailed before, and it's going. What I do try and encourage people to do is to make a good record of carvings. If you've got any interesting carvings, medieval carvings, or even later ones, just for posterity, because once that detail's lost, it's gone. You can't make up what it was like before. Fortunately, here on the other side of the doorway, we can, because it's weathered on one side and not the other, so we can see what it was like. So we could make a faithful replica of that. Next slide, please. I'll open this one to the floor. Any ideas what's causing the crack on the wall there? Ivy, yeah. Possibly also there's this structure that's been dumped on the top of it here, loading the wall. But the main thing is the ivy there growing in the joints and forcing the stones apart. So I encourage everyone to keep walls clear of vegetation as much as possible. Vegetation on roofs. This was Church Knoll. Shillingston, thank you. Shillingston Church.
What an education.
Yes, Shillingston Church, where it's the roof's covered in vegetation, and I have to inspect the church every 5 years. It's a quinquennial inspection, and at my inspection I said, well, I can't tell what condition it's in, I can't see it, but I suspect it's not in very good condition. And we went up and just popped open the roof a little bit near the eaves and had a look, and sure enough, the battens were rotten and the nails had rusted through. And so we started a program of fundraising and specifying repairs. And then about 2 months after that process had started, it takes a long time to get permission for everything and get the money in place. I got a call from the church warden saying there's water leaking into the church, the roof slipped, and I've never seen it like this before. Normally, what happens is all of those tiles at the lower level would be on the floor smashed to pieces. Here, it stopped after just a small amount of movement, so that's now scaffolded, so that there's further slippage, it doesn't land on anybody's head, and the tiles will end up on the scaffold and hopefully not break as well. Yes. All of the nails holding the battens on were rusting, and when I had a look, first of all, there were sort of 2 or 3 which had rusted right through. But there becomes a tipping point where another one rusts through, more load is put on the adjacent one, and then that one rusts through, and then more load, and eventually they all go together. And this is because the moss hasn't been cleared off for many years, and although a little bit of moss isn't really a problem, when it grows into the joints, then it acts like a sponge. It's damp and holds water against the battens. And this has been there for so long, then other plants have grown on the on top of the moss or on top of the decayed material behind the moss. So we've got brackens and ferns and things, and then water can track up the roots particular reaction. Catastrophe, there's a fire. This was made in Newton Church, an electrical fault, and fortunately it's a stone building, so there wasn't actually a huge amount of structural damage done, but a lot of charring and a lot of smoke damage all over everything. Next slide, please. Here, there's another instance of moss on the roof. We've also got a broken corner of the tile, which wouldn't bother me particularly to that extent, but there's a lot going on there, lots of slipped individual tiles, or possibly they're just different sizes. Sometimes when a tile's gone, they'll get another sort of good enough, near enough match and shove it in, but it might be an inch longer than the one next to it. You can't always presume, really. Sometimes you have to open up and see what's going on. So solutions: preventative maintenance, getting the moss off, painting the rusting railings, all that sort of good stuff. Periodic condition surveys, well, I would say that, wouldn't I? Get an expert in to have a look. Maintenance schedules, to plan and schedule things so it doesn't get forgotten, and timely repairs. Have the next slide, please. Thank you. So first case study, this is a leaking roof. So here we've got very, very large pieces of lead on the roof. Historically, there was no British standard or no guidance, whereas now there's the Lead Sheet Training Academy, isn't it? Was the Lead Sheet? Was the association? Anyway, they produce guidance, and every few years it's updated. Lead Contractors Association. We've got the book in the office anyway, and it tells you exactly how much upstand you should have and all sort of stuff. But when this church was last re-roofed, they didn't have the benefit of that. If you notice, there's this kind of slump, and I think that this roof probably was originally in 2 bays, and there would have been a step in the middle. And at some point, someone's just sort of fudged over that. The lead is too big, and it expands and contracts a great deal with hot and cold weather, and with sunlight on it, and eventually it cracks because of all the movement, or where part of it moves and part of it can't, and it splits and it leaks. So if we have the next slide, please. As a result of the leaking, over many years, we found timber decay. And here we've got both fungal decay and you can see the little exit holes where beetles are right there. So woodworm, I suppose that gets called, but there I think we've got both common furniture beetle and the larger holes would be probably death watch beetle. And another problem is that the ceiling underneath, because of the dampness, had also failed. So here we've got the laths, and there should be plaster splodged up through the laths, providing a key to hold the ceiling on. Well, that's gone. So the solution is to reduce the size of the lead sheets, and we've done that by introducing 2 bays. We've kept as much of the existing structure as we can, and added new onto the top of it. So it's quite legible what's old, what's new. So in the future, in 200 years, 300 years, when it next needs to be re-roofed, they can, oh, that's interesting. Crickmay did that. Have the next slide, please. Also, where you have a roof void, you can get condensation forming on the underside. Inside the building, there's people breathing out hot air, heating systems warming the air, and warm air will hold more moisture in suspension, well, more moisture vapor than cold air. And that moisture will rise. There's no vapor barrier like you have in a modern building. And as soon as it hits the underside of that nice cold, wet lead, it will condense. And then the water will start to damage the timber boarding underneath. So we have introduced ventilation. There's a gap at the bottom of this detail here, and then an upstand, so air can flow in and under the gutter and evaporate away any moisture. And we also deepen the sump as well and put an overflow. So if that outlet gets blocked, rather than water pouring inside the building, it'll pour outside the building. Hopefully someone will notice it and unblock it. So that's the finished repair there. That was at St Mary's Church in Bridport. Inside, the ceiling was stained and horrible and damp as well, so we repaired that. So the next case study is Maid Newton Church, that smoke damage. This needed quite a lot of very specialist repair. So these guys turn up on a sort of spacesuit thing and respirators, and we tried a few different techniques, DOT and DOS, various cleaning methods, and then little trials in discrete areas. And what we found was it was the one with the dry ice. Is that DOS? Can't remember which one it is, but which one of the two. But basically, fire little pellets of dry ice at the surface, and the impact of that cleans the soot and debris from the surface and and here you can see before covered in soot and after cleaned up. It's not perfect. It's not absolutely fresh, like freshly sawn timber, because the grain and some of the little hollows in the grain have still got a bit of it in. But it does tell the story. You know, there was a fire there. It also smelled smoky for a few years after it's been cleaned. Still smell. The next case study, this one is a house in Fontmell Magna. Someone had bought it, knowing it was damp. They hadn't had a condition survey done, but they just bought it, they loved it. And it's clearly been repaired in the past. The patches here, there's a patch there suggesting that it probably had a profiled canopy over the entrance. And can we have the next slide, please? So what we did to begin with, we have to understand the problem. Where's the dampness? What's causing it? What's being made of? And then what has dampness actually led to, or consequential damage, and any other issues? So there are a few obvious things. The snapped plate, the gap in the ridge. Someone's tried to fix it a bit with some mortar, but the ridge tile is broken and there's a gap between them. So we'll expect some water to be getting in there. The windowsill, where the paint's blistering off, that's clearly rotten and it was soft to the touch. So there's a good clue there. And we opened up. Opening up, so there's a technical term, means whatever you like it to mean, really. You could just be lifting off the plate and having a look. Could be taking a hammer to things and smashing things up. But here we took off the lining under the ceiling, and this white stuff is the fruiting body of rot fungus. And the edge of that timber is very, very rotten. There's a very technical method of seeing how rotten a piece of timber is, which is jabbing it with, I've got a screwdriver especially for it. And you very soon get a feel for, it goes in a centimetre, well, there's still most of it's okay, or it just disappears up to the handle, that you've had it. And here at the end of that beam, it's going to the handle. Here we are. So this is jabbing something else. Sometimes you end up with requests for drone surveys for inaccessible areas, and there is a place for those. You could see if there's maybe a tile missing, but you can't tell if there's a hairline crack through it. You can't smell whether the timber's rotten underneath. You can't tap it and see is it hollow. So I like to get up close and personal. Here we took off some of the render. So there's a Portland cement render on the outside of the building. And then inside here we found some stone. Can I have the next one, please? And I like to record what we've got. It's good practice to record what we've got. We might need to share that information with other people to get permission or to inform the repairs. So this is a brilliant gadget. Sink in. It's a crack gauge, and it has these lines of different thickness. And just with the eye, you can tell the difference between 0.01 millimeters and 0.02 millimeters. It's a really easy way to measure gaps and cracks and things. So I thought it'd be useful to know how thick that render is on the outside. And also, when the builder opened up, I was there watching some of it to see how easy it was to get off, because that's going to affect the cost of the work massively. And at one point, we were thinking, actually, let's deal with just one facade because we couldn't afford to do both. You have those sort of discussions. Where do we stop? There were cracks internally. We measured those. The top left image, thermal imaging camera, cheap and readily available now. This image is actually of the same place that saw the funnels underneath the window. All it does is tell you that it's colder than elsewhere, but because it's wet, that's why it's cold. Sometimes you can tell where water's coming from. You might have a leak, say, on the underside here, and you can track the cold all the way through along the ceiling. You go outside and look up and see, oh, missing tile or some other obvious defect. Other times, not obvious at all. Then the moisture meter, again, a simple, cheap device. You've got to treat it with a little bit of skepticism, because all it actually does is measure electrical current. And if you've got salt contamination, it can give an artificially high reading, but still it's useful. And magnification to see what type of stone you've got. That's what I was using that for. That was a green sand stone there. As well as physically looking at what's in front of you, there's often documentary evidence. So the listing, if it's a listed building, often has useful information. There is also the geological information, the map that I put up at the beginning, and there's a brilliant little group, Dorset Building Stone, and they're going around the county sort of logging what stone is being used on various buildings, and that's all freely available on the internet. Specialist advice as well. So for that particular project, one of the reasons that I thought some of the damp was arising was because the drainage was possibly blocked or damaged. So we arranged for a camera survey of the drain, and sure enough, the drain had collapsed. And structural engineers' advice. There was quite a lot of cracking and structural movement, so we consulted an engineer. So here we had the building with a mixture of cob, green sand, stone, and brick, and then the whole lot had been rendered over with Portland cement mortar. There were signs of the original lime mortar as well, some of that remaining in places. There's blocked and damaged drainage. The drainage arrangement wasn't very good. It was sort of directing water back towards the house in places at ground level. We had rotten timber and structural movement. Here's a photograph showing you the kind of hodgepodge, patched up type of construction we were dealing with. But anyway, that was all just hidden behind the render. So this is outside, the window that I showed you before with the rot on the inside. This is what we found outside, and the lintel has completely decayed and just turned to dust on the end. And because of that, the wall above had slumped. So this is all cob, so we repaired it. There's various ways of repairing cob. It shrinks as it dries, and so a common way of doing it is to make cob blocks. They shrink, and then you build it with mud in between, and that controls the shrinkage. But what we did here was probably far more traditional. The stuff that crumbled away onto the floor was scooped up and chucked into the barrow with a load of fresh soil. We used a local experienced contractor who knew where the local place to get suitable subsoil was. He mushed it all up in the wheelbarrow and poked it back in. And then the key thing is, he then came back and poked it some more when it started shrinking, and kept on top of it, kept it down, kept poking it back, let it dry out slowly, and controlled it. So although it's very crude technology, it's mud, maybe with a bit of scoring, there's actually a lot of skill in getting it to work properly. So once the cob wall was repaired, we rendered over it with lime. That's the scratch coat going on there. And we used hydraulic lime on that. Went on beautifully. And the next photo will probably show, yeah, there's the finished result. We originally specified a lime wash finish, but it was so good that we decided, well, we'll just leave it. Again, slightly contentious. Tony here, I know, thinks we should always lime wash historic building. I'm of the view that although most old lime, if you look at it now, it's lime wash, it doesn't mean it was originally lime wash. It might have been just left rendered, and then 10, 20 years later, when it starts to look shabby, then the first coat of lime wash went on. It's not really known. Anyway, it looked great, so we left it. Next slide, please. So this one's a rotten gutter. I'm going to pass the microphone to Tony, because he knows about this.
I have talked briefly about Mow House before, so I'll just quickly go through a few small pointers. Mow House is Grade 2 star, mid-18th century, so we think 1730, 1740, Ian? But by the late Georgian period, the fashion was to actually completely change the facade in many respects, because all of this is late Georgian. Before that period, so when it was originally built, it had a very large eaves overhang. We do believe, and I know I've mentioned this before, that we think the building is a bastard of Blanford from the research we've carried out. However, what we discovered was there was numerous water ingress issues with Ian's roof, not just unfortunately a block gutter. Ultimately, there are four main culprits that were causing the problems. Many of the slates simply reach the end of their lifespan. For example, you would expect Welsh slate, Canadian slate to have a lifespan of 60 to 80 years. The leadwork itself has been essentially, and as Daniel's already explained, various issues with regard to inadequate drips, lengths of bay being too long caused fracturing, etc. The other issues we had there were wind damage due to uplift because of nail failure. Again, Daniel's already explained some of this. Rotten battens, and going back, the leadwork ultimately failing. I mentioned slate is about 60 to 80 years old. Leadwork can be several hundred years old. Not in Ian's case, but I don't know if Daniel must have come across some leadwork that is. Yes. I think the earliest leadwork still floating around is about mid-18th century, some on St. Paul's. So all these factors contributed to the water ingress. So ultimately, we made the rather painful decision, or Ian's ultimately painful decision, to have to strip the roof right back. Due to the age and the importance of the building, as you can see, we also had to put a top hat temporary roof over the whole structure to keep it watertight while we completely strip back the roof. The extent, many years of water ingress, we ended up doing an awful lot of timber repair. We recycled about 50% of the slates, and we then brought in another 50% of second hand. That process has changed slightly now. Historic England are more keen that we would bring in new slate rather than second-hand slates due to where said second-hand slates used to come from. So if we were doing this now, we might have taken a slightly different approach, and we may have, say, done two of the roof slopes in the salvage slates and the other roof slopes in new slates. We then obviously did lots of stripping back, lots of timber repairs, salvage slates. One quick trick to tell your slate that you've taken off your roof is down and can be reused is to simply get a hammer, gently tap it in the centre, and if it pings in a nice clear tone, essentially, you know it's sound. If it goes dud, it's essentially past its sell-by date, so we have to move on. Extensive timber repairs, we reformed the lead gutters, and we put it all back together, adding insulation. Is there any more slides? We also, when we took down the parapet wall, that is the original cornice that we took part of one piece, salvaged it, left it on the scaffolding, and put it all back together when we rebuilt the parapet. Space to work.
This is a collapsed wall. It's a retaining wall. Again, it's another church example, but the same applies to any boundary wall. So when we first saw it in 2018, we've got this little area here, just a small localized area. So I suggested let's put a fence around it to make it safe on this side. We'll tell the neighbour as well on the other side that the wall's unstable, stay away on your side, and then we'll set about repairing it. So the structural engineer, this is really a structural wall like this, so we had to get advice from a specialist. They came up with 3 or 4 different options for how we could potentially repair this wall, including putting concrete behind it and all sorts. And the favourite option was to pin it. So here, this diagonal line here, a big steel anchor going into the ground behind. By the time we actually started on site, it had collapsed a little bit more. The next slide, please. So we started work. This is after getting permissions and all the rest of it, specifying the work, getting prices. So they took the collapsed section down, and as they were doing that, they found that, oh, hold on, the bit next to it's not very good either, and they took down slightly more than was on the engineer's drawing, and we agreed the scope on site. You know, well, that bit can stay, that's good enough, and that bit can go. Next slide, please. There were some deep voids within the wall. That's the contractor just right up the armpit. And so this is part that we thought was okay at the north end of the wall, and we found that actually it was in terrible condition. There also, as well as there being big voids in the middle, there weren't any, well, there were very few through stones or bonders. So you've got these 2 skins of stone either side. In the middle should be filled with rubble and lime. Well, some rubble in there. But also there should every now and then be connecting stones connecting the 2 sides together for structural integrity. So one of the first things we did was agree on the mortar to be used. This, as many other historic structures, have been pointed in lots of places with Portland cement, which has probably accelerated the decay. The reason it had collapsed, there was a big tree next to the collapsed section, and you could see roots coming up through the ground. So although the tree was on the lower level, the roots had come up, and we thought that might be part of the problem, which it was part of, but not the whole problem. So we matched the mortar that was in the pointing mortar that had originally been used. The bedding mortar was different, and a lot of the bedding mortar, I think, was actually earth. It might have a little bit of lime in it, but the pointing mortar was a lime mortar. We found that there were lots of roots growing in the wall, not just from the tree that we suspected, but also other plants that had colonised the wall. The adjoining owner had, I mean, it looked beautiful. The opposite side of the wall was covered in vegetation. It looked absolutely lovely, but it really was quite detrimental. To anchor the wall back into the ground, we had some pull tests done. So we had a Syntec anchor system. It's a shoulder-mounted drill, tube thing. It drills back 5 meters or so into the wall, and then there's a bit like I don't know if ever we've used them pullers on the brakes of the car, where it kind of some parts of the car where you pull against the surrounding structure. And we had to load it to 5 kilonewtons, 50 kilonewtons, it might be. Anyway, an immense force. And when we did the pull test, we found that the ground behind was rock solid, but the wall crumpled in. So because there's voiding behind it, so we ended up then having to grout inside the wall to fill all the voids that we couldn't get to it easily. And then the repointing started. So once we've got the thing structurally sound, then all the points are baked out to good depth and dampened down, and then the mortar goes on. Oh, this is just another example of the voiding in the roots. So most of the rubble in there you can pick up, not doing anything structurally. So this is a nice photo. This caused me a little bit of consternation. I was a principal designer under the Construction Design and Management Regulations, which means I've got a bit of a role with regard to health and safety. But the chap underneath that remaining masonry, he made it like that, with his neck on the line, and I trusted him to get it right. So that's Richard Dearden. Years and years of experience doing this sort of thing, and I was surprised when I saw that, but turns out he got it right. He knows what he's dealing with, and so it's a question of using experienced people that really know what they're doing. So he left this remaining arch of stonework up there so that they could excavate that behind and fix things. Next slide. And elsewhere, he used acro props and propped it to take the load down onto the ground. This coping here was redone at the end, but left it in place at this point. And that's held in place because it's been pointed out using inappropriate rock solid Portland cement mortar. So that's how he got away with that. And you can see that behind the masonry, the void is just full of earth and decayed vegetation. So we're nearly finished, and then there was a storm, and a different tree fell onto the wall, which was just what we needed. Next slide. So we had to re-repair the wall, and that was it at practical completion. And we've retained as much historic fabric as we could. We've retained the wobbly old aesthetic of an old wall. There was lots of discussion about whether we should put more new stone in, because a lot of the stones are tiny, they've fractured over the years, but we kept what we could. We did build in a few new through stones and bonders to try and knit it together. And that's it from the neighbour's side. And you can see here the mattresses, the steel plates are the ends of those pins that are anchoring the wall back into the rock. That's Bedminster, the west boundary wall of Bedminster Church. Yeah, you get to see it. Next slide, please. So that's all the case studies. Who to involve very much depends on the project. Us, obviously. But the key is to use competent contractors. If you're using a good contractor that knows what they're doing, take pride in their work, take the time to do things properly, understands what they're doing, you're likely to get a good job. Conservation officer, if it's a listed building, building control, if it's anything that they control, other consultants like structural engineer, perhaps a building services engineer, perhaps an architectural archaeologist to understand the building. And then other people tend to get involved as part of the statutory process. So Society for the Protection of Ancient Buildings, the Georgian Group, Victorian Society, all these other amenity groups. There we are. Everyone with their own little interest and building control don't necessarily care that it's a historic building. They want it to perform well. Whereas a conservation officer, well, he doesn't care about building control. They want to keep the building close to the original if they can. And then you've got a consultant saying, no, you don't want to do it the way the architect says. You want to do it this way. So yeah, you can get a bit of fun when you've got lots of people involved. Healthy disagreement, a lively discussion.
Yes, lively discussion.
But it does. Everyone generally will have the good of the project at heart, and actually, often there are no right and wrong answers. There's lots of different ways of skin a cat, lots of different approaches, which are all valid. So it's good to discuss these things. Expectations. Sometimes people they buy a lovely listed building because they love the way it is, and it's all historic and it's got lots of interest. And then they want it to be warm and crisp and straight walls inside, and you find that they change everything. So there are some buildings that are always going to be a little bit damp. However much you do, it's always going to be a bit wonky. It's always going to have its little quirks. And that's what gives it its charm. If everything was just perfect all the time, it wouldn't be an old thing. And so the patina of age is one of the things that should be valued and cherished. Oh, question. So the question is, lime mortar went its way over time, and it was a good idea to mix in a little bit of Portland cement. And my view, Tony might disagree with me, but my view is no. The fact that the mortar weathers away, and we're talking decades, maybe centuries, for the weather rate of significant amount. I mean, if you lose a centimetre of pointing, it's 2 centimetres deep, it doesn't really matter. So really, it's when it's kind of 2 centimetres or so it starts to be pointed. It might take a century or two to happen, depending on exposure and the type of mortar and those other things. But that's where weathering away sacrificially and saving the stone. So it's good that it's weathering away. because it's slowing the rate of decay of the joining masonry. If you mix in just a pinch of white cement, which is something that people used to do quite commonly, and I've got my suspicions that it might still go on. It makes it easy to work with. It goes off, it doesn't shrink as much, you don't have to keep going back and tending it. It's probably not as susceptible to frost damage while you're working, so you don't have to protect it. It's easy for the builder. Makes it much easier for the builder, and it will look very, very similar, if not the same. White cement, right? It's hard to detect when people have done it. But then the decay is going to affect the stone rather than the mortar. And also it will be slightly less flexible, more likely to crack than the
You mentioned in the presentation quite often use of specialists, expertise and knowledge and labour. I was wondering basically if when you bring in specialists, does it always make sense?
So we've got a question related to architecture teams. Yes and no. Yes and no. You would expect to pay more for someone with specialist knowledge and experience, but you often find that they do it right the first time, and they do it more quickly, and they do it more efficiently. So although their hourly rate might be higher, overall it shouldn't cost more, and you shouldn't get enough price. So, and you probably get more cost certainty as well. The key thing is to get a good foreman. If you've got a good foreman controlling what's going on, that understands the building, and has got eyes on everybody, then you end up with a good job, even if you've got various levels of expertise.
I would like to ask a question about wood and replacing wood, which is good at the best time, with new woods, which often are not up to the job, and that's where one can be tempted to take shortcuts, which are not practical.
Yeah, so particularly bolted pine. And at the moment with Russia waging war on the world, we don't really want to be putting money into their coffers by specifying wood from Russia or Russian controlled territories. So with pine, slow growing pine is much denser, has much tighter grade and is stronger. And more rock resistance is generally better, all that. And so around about 18 like that. Can't remember off the top of my head, but sometime in the 1800s there was a big expansion in imported bolted pine, and that can be complete in the northern hemisphere. But where the pine's grown really slowly in cold environments, it's just better quality, and you could get that from Russia, and you probably still can get a great expense FSC certified. Yeah. There's a scheme, FSC, so Forestry Stewardship Commission, I think it is, where they will undertake to plant more trees, so over time we don't have to take the forest and the practice and the well safe. You can get that, but the high quality bulk pine, FSC certified, would be quite expensive.
Well, thank you so much for your intervention, and we've learned a lot and told us a lot of amusing tales on the way. And well, we wish you luck with saving more buildings in the coming year. Thank you again.